Special triangles are kind of tough to understand at first, but once you get the idea of it and once we get going, you're going to find that it's actually pretty simple. So all I'm asking is just be patient and learn as you go here. So you actually did some of this again in geometry. If you have a right triangle, let me make a different right triangle. There's two special triangles that we look at. Okay, the first one, the easiest one to look at, is the 45, 45, 90 triangle. So we have two 45 angles and then one 90. And if you notice, it's isosceles, which means these two sides are going to be the same. So we have the sides. And so what we'll do is if we call this one and this one, then that means if I do the Pythagorean theorem, if you don't remember, it's a squared plus b squared equals c squared. We will need that this semester. If I do the Pythagorean theorem, I get the square root of 2 for the hypotenuse. So if I go through and do my trig ratios, sine of 45 degrees, now since both of them are 45, we can just pick one to look at. Sine is the opposite over the hypotenuse. And then I have to rationalize that. So I square root of 2 top and bottom, and I get the square root of 2 over 2. So sine is root 2 over 2. Cosine of 45 degrees is the adjacent over the hypotenuse. And then I once again have to rationalize and I get root 2 over 2. And then tangent of 45 degrees is the opposite over the adjacent, which is just 1. Well, then we can also throw in our reciprocal identities or reciprocal ratios. And so we have got cosecant of 45 degrees, which is the reciprocal of sine. Now I'm going to, when I do the reciprocal sine, I'm actually going to use this, because if I use this, then I'm going to put the square root on the bottom again, and then I have to rationalize. But if I use this, and I go back, I get root 2 over 1, which is just root 2. Secant of 45 degrees is, I'm going to take the 1 over root 2 and flip it. We get root 2. Not a surprise that they're the same. And cotangent of 45 degrees is 1 over 1 flipped over, which is again 1 over 1. So that's the simple one. That would be 45 degrees. Then we have the one that's a little bit more difficult, and that's the 30, 60, 90. Okay, so we have 30 degrees, 60 degrees, and 90 degrees. Now, if we go through and label these, this is side 1, this would be length 2, and then the Pythagorean theorem would give us a square root of 3. I want you to note the square root of 3 is next to the 30. It's adjacent to the 30 always. So that's one thing that helps me remember the sides, is the 3's go together. 2 is the biggest number here, so 2 is the hypotenuse, and that leaves 1 for the rest. Otherwise, it's 1, 2, 3, basically. And so here, now, I actually have quite a bit to go over, because if we first start with 30 degrees, we've got sine of 30 degrees. That would be opposite 1 over a hypotenuse 2. And then if we flip it over, cosecant of 30 degrees would be 2 over 1, which is just 2. Cosine of 30 degrees is adjacent over hypotenuse. And then secant of 30 degrees is hypotenuse over adjacent. I have to rationalize, and we get 2 root 3 over 3. Tangent of 30 degrees is opposite over adjacent. I have to rationalize that, so we get root 3 over 3. And cotangent of 30 degrees is adjacent over hypotenuse, adjacent over opposite, which is just 1, so it's just root 3. Now I also have to worry about the 60 degrees. So now I have sine of 60 degrees is opposite, root 3, over hypotenuse 2. And then the cosecant of 60 degrees is, I flip that over, and then I have to rationalize it. So then I get 2 root 3 over 3. Now we have the cosine of 60 degrees. That would be the adjacent over the hypotenuse. That's not adjacent, is it? I was looking at 30 degrees there, sorry. Okay, so the cosine of 60 degrees is 1, adjacent over the hypotenuse 2. And so then the secant of 60 degrees would be, flip it over, 2 over 1. Tangent of 60 degrees would be the opposite over the adjacent, so I just get root 3. And cotangent of 60 degrees would be the adjacent over the opposite. And then I rationalize that, so I get root 3 over 3. All right, so those are our special triangles. We're going to get to know these numbers a lot. We're going to use them a lot. So these are called your special triangles.